Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to look at implicit differentiation. Let's do some examples. The directions say to find dy dx by implicit differentiation. In the first example, part A is x squared plus y squared equals 25. Solution. So to start this problem, we will differentiate both sides with respect to x. Normally people don't write the notation I'm going to write, but since this is the first example, I'm going to write it. So d dx of the left-hand side, so x squared plus y squared, is equal to d dx of the right-hand side, so 25. Basically, this is just indicating that we're going to differentiate both sides of this equation. Okay, let's focus on the x squared. Normally, when you differentiate x squared, it's very easy. You bring down the 2 and you subtract 1 and you just get 2x. But let's try to think about it in a deeper way. So we can think about it via the chain rule. So we can bring down the 2, subtract 1 from the exponent, and then we multiply by the derivative of the inside function. The chain rule says that you're always supposed to multiply by the derivative of what's inside. The inside function in this case is just x, and so its derivative is simply 1. Another way to indicate that would be to write the derivative of x with respect to x. But that just cancels and you get 1 anyways. So most of the time, we don't worry about stuff like this because there's no need to. Now let's do the same thing with y squared. So plus, we bring down the 2, we have a y, we have the first power, and then times the derivative of the inside function. In this case, y is some unknown function of x. So its derivative is going to be dy dx. And that's the key step. Basically, whenever you're using implicit differentiation and you have a derivative that involves a y, you're going to put dy dx. And that's always going to be the case in problems where you're looking for dy dx. And this is equal to the derivative of 25 is 0. Right. So here we have 2x plus 2y dy dx, and that's equal to 0. So now we have to solve for dy dx. We can subtract 2x from both sides, minus 2x minus 2x. So we end up with 2y dy dx. And that's equal to negative 2x. Because dy dx is being multiplied by 2y, we'll just divide by 2y. So divide by 2y, divide by 2y. These cancel. And so we end up with dy dx is equal to 2's cancel, so we just get negative x over y, and that would be the derivative of y with respect to x. This next example is a little bit more challenging. We have x squared y cubed plus y squared equals 4. Let's go ahead and work through it. Solution. In this particular problem, we are going to have to use something called the product rule. I'm briefly going to refresh your memory on what that is. Recall that if you have two functions, say f, and another function here, say g, and you're multiplying them and you want the derivative, think of f as your first function and g as your second function. And the product rule says it's the derivative of the first, so f prime times the second, so g plus the first times the derivative of the second. So the way I think about it is first and second instead of f and g. It just makes it a little bit easier. So derivative of the first times the second plus the first times the derivative of the second. Okay, let's go ahead and differentiate both sides of this equation. Right away, when we do that, we're going to have a product here. We have x squared here, and then here we have y cubed. So taking the derivative of the first, it's going to be 2x times the second, so y cubed, plus the first, so x squared, times the derivative of the second. So we have y cubed, we bring down the 3, we subtract 1 from the exponent, and then times the derivative of the inside function, which is dy dx. Again, whenever you are differentiating a y like this in these problems where you're looking for dy dx, you want to be extra careful when you're differentiating terms with y's. Let's just double check this. We're still not done with the process. So derivative of x squared is 2x times the second plus the first, which is x squared, times the derivative of y cubed, which is 3y squared dy dx. And again, that dy dx is the derivative of the inside function. The inside function here is y, and its derivative is just dy dx. We have a plus sign, so plus. And again, we have a y squared, so same thing. 2y times the derivative of the inside, which is dy dx. And all of this is equal to 0 because the derivative of 4 is 0. All right, I'm going to show you how I simplify this, and I think it's good. That's the way I do it. So we're going to factor out a dy dx from everything here I've underlined. So we have dy dx, parentheses, and let's see what's left here. 3x squared y squared, 3x squared y squared, then plus a 2y. And then this term here, 2xy cubed, we're going to bring it to the other side, so it will become negative. We get negative 2x y cubed. Since dy dx is being multiplied by this huge expression, we're going to simply divide by it. So we have dy dx equals negative 2x y cubed divided by that huge expression, which is 3x squared y squared plus 2y. And unfortunately, we're not done. There's actually something else that we can do here. It's basically to factor out a y in the denominator and cancel. So we have minus 2x y cubed, and in the denominator, we have a common factor of y. So y parentheses 3x squared y plus 2. Really easy to forget to do that. And then, so now we have our final answer. Let's clean it up. It would be dy dx is equal to, we're left with a negative 2x y squared in the numerator. And in the denominator, we simply have 3x squared y plus 2. And so that would be the derivative of y with respect to x. Hopefully after watching this video, you have a better understanding of implicit differentiation. If you want more examples, be sure to check out Chegg, because I do know they have examples, including video examples for problems similar to these. I hope this video has been helpful. Good luck.